So f is a one-to-one function, then f inverse is the inverse function of f. If the composite function of f and f inverse equals x for every x in the domain. And the opposite is also true. F inverse is a composite function of f also equals x for every f in the domain. So note the f to the minus 1 is the notation for inverse of f. It's pronounced f inverse of x. So this is not f to the negative 1 exponent. This is just the one that we use to mark inverse. So if I want to verify that these pairs are inverses, I need to find the composite. So I need to go f of g of x. So I need to put 4x plus 9 into the f function. And if it is an inverse, it should just simplify down to x. So we're going to go 4x plus 9. So I'm replacing this x here, minus 9 over 4. So I can see here positive 9, negative 9. Those are going to cancel each other out. I'm going to have 4x over 4. So it did just simplify down to x. So now we're going to test it the other way. So we're going to try g of f of x. So this time into my g function, I'm going to sub in x minus 9 divided by 4. So I'm going to replace this x with this right here. So we're going to have 4 times x minus 9 divided by 4. And then we have the plus 9 at the end. So this time, if I'm multiplying 4 and dividing by 4, so we have x minus 9 plus 9 equals just x once again. So these two are in fact inverses of each other. So let's try one more here. So I'm going to try this one. So I'm going to start with f of g of x. Doesn't matter which one you start with. So in f, I'm going to shove in 3x minus 2. So again, we're going to replace this x with 3x minus 2. So we're going to have 3x minus 2 plus 3 all over 2. So if I negative 2, positive 3, that's going to give me 3x plus 1 over 2. So there is no way that I can simplify this down in order to get just an x. This does not equal x. Therefore, f of x and g of x are not inverses. So there's one more here for you. I want you to see if these two are in fact inverses of each other.